We've looked already at velocity in terms of problem solving from that standpoint. And now we want to look at the concepts behind that and what it means in terms of frame of reference, displacement, time, velocity. And then we want to practice again calculating the displacement of an object traveling at a known velocity for a specific time interval and do some comparisons there. To look specifically at one-dimensional motion, think of yourself as walking from point A to point B, like maybe down a hall over a specific period of time. You're walking at this point in a frame of reference. And a frame of reference is a point at which you can measure changes in your position. The frame of reference will stay fixed throughout the problem or the scenario that you're working with. An example would be walking down the hallway. The doors that you pass would not move. You would move along with the hallway and the doors around the sun and through the universe. But with respect to your frames of reference is what you're going to measure against. So if you are at rest, your position will change with respect to the other things in the universe, and so do the hallway and the doors. Okay? So as you're walking, you can think of the floor as a meter stick that you would measure your position as you walk down the hallway. We have to distinguish a couple of things. First, displacement versus distance. To look at displacement, we're going to compare this to distance, and that displacement is a change in position. We represent change with the symbol delta. Okay. So let's say, for example, you were going to start at point A, okay? And you then walked a little ways in one direction and then maybe another direction. When you change direction again and again, then you double back maybe. Look at all the times that you're changing direction here. Where you're really trying to get is point B. And you might have changed direction all those times just because you had an errand to do in each of those places, or maybe you were going for a jog. So if you were to look at this, you would be measuring your distance. This is quite a long distance. If you counted all the blocks, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You have quite a lot of blocks. So this would be the actual amount of distance that you walked. Now, if we were talking displacement, displacement is just a difference between the initial position and the final position. So it's going to be the final position minus initial position. And we would show that as displacement is going to be delta x. We'll represent that. Remember, delta being the change. And that's going to equal, we'll represent final position with xf minus initial position of xi. Okay? You can see clearly here that displacement might not equal distance. Okay. A couple more things about displacement. Displacement can be positive or negative. In general, if you were looking at that imaginary ruler on the floor, so let's keep those equal. Okay, and if we're going to look at 0 as being the initial starting point, if you were to move 8 meters to the right or away from 8 meters to the right or away from the starting point, you would be moving plus 8 meters away. Also, if you think about right and left and east and west, right would be considered positive or east. Now, after you did that, if you turned and you walked back the other direction, maybe you walked back 6 meters in the other direction, you would be going minus 6 meters. You would be going toward or reversing your direction, left or west. Okay. We also consider this south, and if you were going in a positive direction, you would be going north. Okay. Okay. To do some simple calculations with this, we can look at velocity then as being equal to the displacement over the time interval. Okay, displacement being the actual point A to point B, or as the crow flies distance. And we can also represent that in symbols because it's much shorter as delta x over delta t. Remembering that delta x is the final position minus the initial position over the final time minus the initial time. Okay, this is change in position over change in time. And the magic part of this that you probably want to record, which you can put on a note sheet of some kind if you like, is this equation right here. You'll be able to put that on a note sheet and use that all the time whenever you need to take a quiz. It's your little bitty cheat card, okay? So if we think about this, the average is going to be positive if the object is moving away to the right, to the east, or to the north. The AV is going to be negative if object is moving toward to the left, to the west, or to the south. Okay. An example that we'll look at quickly. If you were going to drive from Waynesfield to the Ohio State University, okay? The Ohio State University is about 76 miles, and it's more or less south. It will take you about an hour and 11 minutes. Okay, which happens to equal 71 minutes. Okay, let's look at how you would set this up. Looking at this, you're going to see that you have some givens, and you're given, you have a delta x of 76 miles, and that's going to be south. You have a delta t of 71 minutes. Okay. So your V average is going to be this equation, delta x over delta t. And when you plug in your values, you have 76 miles over 71 minutes. And that gives you 1.07 miles per minute. Now, we don't usually measure our speed in miles per minute. We tend to talk about speed in what our car odometer reads us. So the 1.07 miles per minute needs to be converted to miles per hour. So we can use a conversion factor there of 60 minutes in 1 hour. And doing a little bit of math there, you would multiply the 1.07 times 60, and you're going to get about 64.2 minutes, which is going to be just over an hour. So you can see here why it's very important that you watch your units carefully, because if you didn't write down the units up here, you would think that that was maybe miles per hour, which is really pretty slow, and it would take you quite a long time to get there. So this would actually take you an hour and 44.2 minutes.